Good morning, dear students. Let us discuss the new concept that is energy. Energy in physics, we call it as capacity to do work. Work in physics, I have told you, that is equal to force into distance or displacement. So, all of you know that for doing any work, we need energy. कोई भी काम करना है तो आपको एनर्जी चाहिए एंड ऑल ऑफ यू नो सन इज द ultimate source of energy. From sun we get light energy, we had energy, heat energy, and so many forms of energy. So in this chapter we are going to discuss the energy possessed by non-living object. So does the non-living object possess energy? Do they work? Let us consider the example. We throw a cricket ball and then this moving cricket ball hit the stumps. Means it does some work. Or consider another example. We had a cardboard, a pin over here. When we release a hammer on it, the pin goes into the cardboard. That means this hammer and ball are doing some work. Means they possess energy. Hammer hits on the pin goes inside. That moving hammer has some energy. Moving ball can hit the stumps, means moving ball has some energy. Means moving object can do work, they had energy, which is known as moving energy, or in physics we name it as kinetic energy. So what is kinetic energy? The energy possessed due to the motion of the object. Water waves has also energy as they are moving. Now question arises, does the object has energy without motion? Let us consider. We had a spring. If we compress it and keep a paper ball in front of it, when we release our hand, then this spring will push the paper ball. Means it has some energy. When we released our hand, then that energy has been changed into kinetic energy and paper has moved. Similarly, stretch a spring and put a paper ball over here. When we leave, then also this rubber can move this paper ball. Question arises, on what factor the energy depends in this spring, or you can say stretch rubber? Means how can we increase the energy in this spring and this rubber? You know very well, if you compress more and release your hand, then it will move the paper ball with more energy. Or when you stretch more this rubber and then release, then it will shoot the paper with more speed. Means the energy depends upon its configuration. Let us consider one more example. You had a ball. You take the ball and release the ball through some height. On this ball, the gravity is also working. So due to gravity, it is falling on the earth. Means gravity is doing some work on it and gravity has some energy. If I want to increase the energy by gravity, what should I do? I will raise the ball up and the energy by gravity will increase. Means in all three cases, the energy depends upon configuration or position, means at what height the object is. So this energy is known as potential energy. In this chapter, we are going to discuss these two forms, potential energy and kinetic energy. The energy possessed by the virtue of object, means by its position and configuration, that is known as potential energy. And when potential energy comes into the motion or the energy possessed by the motion of the object, that is known as kinetic energy. And all of you know, energy is neither created nor destroyed. It can change one form to the another form. In this case, the energy is called as gravitational potential energy, or you can say potential energy, because the energy in the ball is due to gravity. In these two cases, the energy, potential energy, can be called as elastic potential energy, means this energy is due to the elasticity of the object. We have learnt energy is capacity to do work, that is F into S. So we have going to study two forms of the energy, that is kinetic energy and potential energy. Kinetic energy is due to the motion of the object. If object is moving fast, then it has more energy. If object is moving slow, it has less energy. Similarly, potential energy, if we consider this example, potential energy due to gravity at less height, it has less energy, and if we raise up to more height, it has more energy. Means energy depends upon height. And in case of this spring, if we'll compress less, it has less energy, and if we compress more, it has more energy. Basically, potential energy is change into kinetic energy. So these are the two forms of the energy, and we will discuss the derivation of this kinetic energy. What is kinetic energy and its derivation? Kinetic energy is the energy possessed by body due to its motion. Kinetic energy of an object increases with its speed. If motion of the object is more, speed is more, and kinetic energy is more. Kinetic energy of a body moving with a certain velocity means work done on it to make that velocity. Means kinetic energy, basically the work done by the object. That is the kinetic energy. Let us derive the equation for this. Consider an object of mass m starts from rest and attains a uniform velocity v after a force F is applied on it. We had an object of mass m and it starts from rest. If we apply some force on it, it has some velocity, that is v. And during this period, the object displaces by the distance s. As we know, we are applying force on an object and object is moving a distance s. So work done on the object W is equal to F into S. Let us calculate the acceleration produced by this. The acceleration produced after applying force, suppose A. According to third equation of motion, which we have already studied, we know v square minus u square is equal to 2as. So v square minus u square is equal to 2as, or we can calculate s from here, that is equal to v square minus u square upon 2a. And force, we know force is equal to F into m into A. Substituting the value of F and S from second equation and third equation in first equation, which is W is equal to F into S. Put the value of F, that is equal to MA. Put the value of S, that is equal to V square minus U square upon 2A. Now A will be cancelled. U is equal to 0 because the object is starting from rest, so initial velocity will be 0. So W is equal to half mv square. Therefore, work done on the object is equal to, you can say, energy of the object, that is equal to half mv square. Work done on the object is always equal to change in kinetic energy of the object. So kinetic energy of the object is written like this way, half mv square. This derivation, this formula we will be using in the numerical problem. Try to understand it, and if you have doubt, I will repeat this.